Hello everyone. So today we're going to do the chapter called data structures, and under that chapter called data structures we are learning the topic called stack. Okay, we've already studied the data structure array. So now let's look at the stack today. So what is a stack? A stack is called a LIFO data structure. Now what do I mean by the word LIFO? Last in, first out. Now to understand this, let me just show you a pile of plates here. Okay. Now when you add plates onto this stack, obviously where are you going to be adding it? On the top. And when you're going to be removing a plate, which one are you going to be removing? The topmost one, which means the last plate that you added to the stack of plate is the first plate that you are going to remove when the removal of a plate is done. That is what it means by last in, first out. So now you might wonder, this is all about plates. How do I use it in computing? Okay, let me give you another example of where a stack is used. Let's assume you are working on some text editor and you have performed the following functions. Okay, I've just written some functions there and I'll tell you how a stack is used here. So for that, let me just animate it a little. Okay, so the first operation, excuse my stacks diagram, the first operation you are doing is type. Okay, so you have typed something. So what have you typed? So the operation performed was type, and what have you typed? Hello. Okay, after typing hello, what is the second operation you have done? You have changed the color. Okay, so you have changed the color. Okay, the color has been changed. After that, the next operation you're doing is underlining the text. Okay, so let's say you have underlined the text. Now if you have used any text editor, you remember when we do undo, what does it do? It will undo the last operation that was performed, which means now this is the stack that I've drawn here. My stack first consists of typing of hello. The second element in my stack is changing the text color. The third element in my stack is underlining it. Now when I'm undoing something, I am going to pick up the last thing out of the stack, because stack says last in, first out. So what will I undo? The underlined text is going to be undone. Okay, so now underline is no more a part of all the functions that I'm doing. I have an undo operation once again. So what does it do? It goes to the stack and picks up the topmost element. Now after you've removed underline, what remains in the stack is change of color. That is also removed or undone. So now what is happening? You're just left with the typed hello text on your screen. Okay, and you're continuing with your operation. It says make it bold. So then finally you go and make it bold. But now remember, in the stack you don't have these two operations. Okay, change and underline is no more there. After type, it's bold. After bold, you are saying make it change the color to blue. So I change the color to blue. So here an undo operation also has a working of a stack, where the last operation that you performed is the first operation to be undone, which means it is using the concept of LIFO, last in, first out. Okay, let's talk in terms of a Python program. Am I using a stack in a Python program? Yes, there is a stack always used whenever you are executing a Python program. And what is that stack used for, or how does it help me? Okay, if you look at the program given to you here, you have three functions: function 1, function 2, function 3. But we know program execution doesn't begin from any of these functions. Program execution begins from main. Main is at line 14 and 15. So what happens is there is a stack, okay, which initially stores where the program execution is, and the program execution is in the part of the program named main. If you remember from the functions chapter, we said main is named as underscore underscore main underscore underscore. So let's say this is the underscore underscore main underscore underscore is initially there in the stack because program execution starts from there. Now what is line number 14 doing here? Is it calling a function? Yes. Whenever a call to a function is made, the name of the function along with, so which is the function? func1, the name of the function along with the location from where it was called. According to this, it's on line number 14. But generally when I say location, it doesn't necessarily mean the line number in Python. It means where it is in memory. Let's assume these are memory locations. So func1 along with the location from where it was called is pushed onto the stack. And what happens? I go and start executing that function. So the first output I get is this. Okay, it goes to function1, executes this line which says ending function1. So that's the first output I get. Okay, and what have we learned? Whenever we finish a function, what exactly happens? When you called a function, the name of the function along with the location from where it was called is pushed onto the stack. When you're done with a function, the name of the function along with the line from where it was called is removed from the stack. So this is removed from the stack, and when I remove this, I realize that I have to return back to line number 14, and that is the reason after executing function1, it doesn't go anywhere else. It goes to line number 14 and then continues with the program. Now I have something at line number 15. So am I calling the function again? Yes. So what gets into the stack is the name of the function, which is function3, and the location from where it was called. So it was called from 15. And what happens when I call function3? You jump to function3 and start executing function3. So the first output you're going to get is calling function2. So that's the second output that I get in the total program. Then you're calling function2. So what did we learn? Whenever you call a function, the name of the function, that's called the call frame. Okay, the frame consists of, it's a memory location where it consists of the name of the function and the location from where it was called. Okay, it's called from 9. And what happens? You go to function2 and it's doing a statement ending function2. So that's my third output. Now what happens when I finish a function? See, remember function3 is not over. We're halfway through function3. But we have finished function2. When you finish a function, what did I say? It will go and pick up the topmost element out. So it picks up this topmost element out. Okay, that was calling function2, correct? So it'll pick up that topmost element out and it gets the location 9. So it returns back to location 9. It comes to location 9, then it goes to location 10. So this is your fourth output to be displayed. Okay, then it's calling function1. When you're calling function1, what happens? Into the stack you are entering function1, and from which location are you calling it? From 11. Now remember, the cancelled ones are no more in the stack. Okay, I can't keep showing you a changing stack, so I'm just deleting it. So basically now in the function is main, function3 and function1. Function1 called from 11th location, function3 called from 15. So I go to function1. When I go to function1, I again get a message ending function1. So that's my fifth output. When I'm done with a function, what do? I pick it out from the stack. Okay, go back to the location mentioned here, which is location number 11. So I go back to 11. Then after 11, the next line says print ending function 3. So that's my sixth answer. Now I am done with function3. So what do? Whenever you're done with function3, go to the stack and pick up the topmost element. Now the topmost element is this. So you pick this up and you get the location where you have to return. That's 15. So you get back to 15, and after 15, when I move down, I realize that that's the end of the program. And main, when the program ends, even main is out of the stack. Why is main automatically put into the stack? Because we know that program execution begins from main. You don't call the main part of the program. Program execution begins from there, and then you keep calling other functions. So if you see here, A stack is used in every Python program that you will be writing, especially when it deals with functions, because it keeps track of where to come back once a function is executed. Okay. So what are we going to be doing now? What we are going to do is we are going to be learning to simulate a stack using a list. Okay. And the two operations that we just saw, what were we doing onto the stack? Either we were pushing something onto the stack, so that's called push. Adding something into the stack is called push. Or we were removing something from the stack, and that is called pop. So two operations that you perform on a stack are push and pop. And with respect to our list, I can do the push operation by making use of a function named as append. List has a function named as append, and I can do the pop operation by actually making use of a function named as pop. Is that clear? Okay. Now, another thing that you need to know is there are three terms that we use when we talk about stack. The word peek. Peek says, find out what is the topmost element, not remove it. Pop actually removes the topmost element. It also finds out and removes, but peek is only to find out, not deleting it. Underflow term. Suppose I have an empty stack and I pop elements. There is nothing in the stack, right? So that concept is called underflow. That means stack is empty. Then there is a term called overflow. Now when we are using list in Python, we are not going to be seeing the overflow concept. Reason being, in Python, the list can increase in size. It's not a fixed size, it's not a static list. It can increase in size as you execute the program. But in certain programming languages, when you use a stack, you have to give a size to it. And let's say you give a size of 5, which means more than 5 elements you cannot insert. That concept we do not have in Python is because we allow elements to be added into the list as and when required. Is that clear? So did you get a gist of what a stack is and where stacks were used? Now, from exam point of view, you need to know the next program, which is a simulation of a stack using a list. Okay, so let me just share my screen with you. Okay, so I bring you to the Spider IDE. I have created a stack using a list which is currently empty. I have used a variable called top, which is currently none. That means not talking about any specific value. Okay, now what is the variable top's role? Stack is a LIFO data structure where insertion and deletion both are done at an end called the top of the stack. You remember? Adding was on top and deletion also was on top. So in my program, what is top going to do? Top is going to be telling me the location of the last element that was inserted, or where the last element is, whether it's after insertion or deletion. Where is the last element is going to be told to me by the variable called top. Okay, I am implementing this program using functions. Okay, so I will have a push function to add an element, pop function to delete an element, peek function, I told you peek is to tell you what the topmost element is, and the display function to see the elements of the stack. So I've created an empty stack initially, and top is equal to none means no value, no specific value to the variable top. I've defined a function called push, and we just said in the previous, in my PowerPoint that how do I push something onto a stack is by making use of the append function. So I have written stack.append x. What does the append function do? We already know it's going to be adding the element x to the stack, and then I'm displaying a message, so and so element is added to the stack. And then now what happens now? You have added an element that is going to be at which index location? 0. So I want top to refer to that location. So how do I get 0? What would be the length of the stack after adding one element? 1. 1 minus 1 is 0. So I brought the variable top to location 0. Now you might get confused about why I wrote global top. You remember in the functions chapter I said if you want to make use of the global variable in a function without creating a local variable with the same name. If I hadn't written global top, what would the push function do? It will create a local variable with the name top. I don't want that. Throughout my program, I only want one variable called top to be used. Therefore, I wrote global top, which means the top variable that I use in this function is talking about the global variable top, and it is assigned the length of the stack. So in this scenario 1 minus 1, which is 0. Yes, the first element is at 0th location. Okay, now let's say I call the push function once again. So what will happen? One more element gets appended, a message will be displayed, top will become length of the stack, that is 2 minus 1, which is 1. Yes, if you have two elements, the last element is going to be at index location 1, and so on. So you can keep pushing as many elements as you want, and top gets updated by the value that you push. Okay, coming to pop. Okay, if you use the function pop of list when there is nothing to pop, you would get an error message. To avoid that, I have written a statement like this. If top is equal to none, none was its initial state, okay, which means there's nothing in the stack, I am giving a message stack underflow, because what will I pop when there is nothing in the stack? Otherwise, what do? I pop the element, and the popped element, I'm storing it into a variable called item, because we know that the pop function returns the element that is popped. Okay, remember one thing, pop, if you remember the list manipulation chapter, pop also takes the index number. I could say pop 2, 3, it would pop out that element, but we want the last element, and for the last element it's always pop without parameters. Okay, now after you pop, what if the length of the stack becomes 0, which means you popped the only element that existed in the stack? Doesn't the stack become empty? Yes, but what should happen to top? Should top be talking about any index location? No, it should come back to its initial state of none. So I bring top to none. But let's say there were 5 elements and you popped one element, okay? Will the length be equal to 0? No, it's going to be equal to 4. But will top be pointing at index location 4 or 3? 3. That is the reason I said top is equal to length of the stack minus 1. Okay, so whenever you are deleting an element, you will recalculate the length of the stack, and minus 1 is obviously the last element is at length minus 1. Okay, that's where the top is going to be. But if you deleted an element and that was the only element in the stack, obviously what would it mean? Length of the stack is going to be 0, because the stack is going to be empty. Then in that scenario we bring top back to none. Then I have a function called peek. What is peek? I told you peek is just telling me what the last element is. It's not going to delete it, it's just going to tell me what the last element is. So it's displaying stack of top. Okay, then coming to the display function, I want to display the elements of the stack. Now people would say, just say print stack. Yes, print stack would display all the elements from the first location to the last location. Whenever we talk about stack, the elements are printed from the last to the first, because the last in first out concept, right? So if top is none, that means if you did not have a stack existing, top would be none. I'm giving a message underflow. That means I have nothing to print. Otherwise, look at the loop. I start at top, which is the last location, and I come backward and I keep printing the elements. Okay. Now, if you're having this question as a practical question, you would probably have a menu-driven program, which would say option 1 is push, option 2 is pop, option 3 is peek, option 4 is display, and depending upon the user's choice, you could be calling any of those required functions. I've just randomly called the functions here. I called push 3 times. Then I said peek, so peek will tell me the last element, which is supposed to be 7, okay? Then I called push once again. So now what are the elements of the stack? 3, 5, 7 and 10. 10 being the last one. So when I displayed it, then I popped 2 times. So which 2 elements will be popped? The last 2 elements, which is 10 and 7. And what will be left in the stack is only 5 and 3. Why am I saying 5 and 3? I'm going backwards. Okay. So let's see if it's the same thing. So I execute the program. Okay, element 3 was added to the stack. Yes, element 5 was added. Element 7 was added. Peak is telling me the topmost elements. The topmost element is 7. Then you said push 10. So element 10 got added. Display is displaying the elements of the stack from top to, from the last to the first. So you have 10, 7, 5, 3. Then you said pop and pop. So element 10 is deleted. Element 7 is deleted. Now I said display. So what's left in the stack? If you remove 10 and 7 from here, what's left in the stack? 5 and 3. Is that clear? Now this is going to be like a kind of a sure shot question, because normally they will ask you either the program using a stack or a queue. So either the stack program or the queue program, or it could be a choice between stack and queue. You are going to be seeing this question in your question paper. Is that clear? So I hope the concept of stack is clear. And remember, you might ask, why are we using stack in Python? How does it help us? No, we're just simulating a stack. That means using Python programming, we are making a program that behaves like a stack. I told you stacks already exist. I'm just simulating one with this program. Is that clear? Okay, bye. Thank you.